Hey, what's happening, guys? I'm Mr. Ernst here. We are 12.2 today. Arithmetic sequences. And partial sums is going to be the second part of this. So thank you guys for completing the formative. Also, congratulations to Mr. Moore. Noah John was born and is healthy and is happy. I actually just talked to him, just got to see the little guy. He didn't sleep phenomenally well on his first night home, but keep your fingers crossed that tonight, Sunday night, will be a little bit better. Anyways, hope you guys had a good weekend. We had awesome weather today, so hopefully you got to get outside. So Monday morning, we're hitting up arithmetic sequences here. It is something that I think you're going to find to be pretty straightforward. We've actually been working with arithmetic sequences, and they're the simplest sequence that we're going to talk about. So thus far, we've examined many different sequences. The sequences whose consecutive, that just means next to, consecutive terms have a common difference. Ooh, it is funny. Writing on an iPad. Common difference is known as an arithmetic sequence. So this is pretty straightforward, okay? I'm just going to jump into example 1 here because I think to be able to explain it is easiest with examples. If we look at letter A, this is very obviously a yes, because plus 2 plus 2 plus 2 plus 2. So in that light, you can see arithmetic sequences are a piece of cake. Are we moving from the same? Are we moving by the same number to get from the first term to the second term to the third term to the fourth term? So you could pause the video right now and try B, C, D, E, and F on your own, but I'm pretty sure that you can tell that this one is absolutely no, because this first one would be plus 2, and then we'd have plus 3. You don't even have to keep going there. We know that the answer is no, because those two differences here are not the same. Okay. Letter C. From -3 to 6 is plus 9. And this is, minus 15. That's already a no. D. Let's see here. This one looks like a yes. The common difference can be negative or positive. It doesn't matter. That would be yes. And we're going to jump right here and say that D equals -5. I'm kind of previewing the next part here, but what's D going to represent? It's going to represent the common difference. Up here, D was equal to 2. Okay. And so E is... There's definitely a pattern going on here, but we're doubling. So that is a no. A difference has to be either addition or subtraction. So that's plus 3, plus 6, definitely a no. And this one, I don't know what this one is. This is definitely also a no. Plus 3, plus 5, plus 7 is not arithmetic. Doesn't matter what it is, but it is not arithmetic. Okay? All right, so just like we had done in the past, this is probably one of the harder things that we've done, is finding the general term, or general definition, I should say, for a sequence. So we're going to kind of lock it down for you here. When we're talking about an arithmetic sequence, basically what you're going to need is a starting point, okay? So to find any term here, okay, the one that we're most commonly going to use is going to be a sub 1, the first term, plus D, which is the common difference, times n minus 1. Okay, I'll explain that in just a second. But first, I'm going to start with the simpler one that we don't use nearly as often. A sub n is equal to a sub 1 plus D times n. Okay, now hopefully the second one makes sense to you, because if you start with the 0 term and you want to get the first term, you just take 1 times the common difference and add that to the 0th term, okay? So for example, if we say that we have a sequence that starts with 4 and the common difference is 5, what's the second term going to be? 9. Okay, how did I get that? I added 5. We would have 4, our 0th term, plus the common difference, which is 5, times 1. Okay, to find our second term, we would take 4 plus the common difference, which is 5, times, if we want to find our second term, it would be 2. So that's going to be 14, and so on and so forth. Do you follow? Hopefully that this second one that we're not going to use as often makes sense. So why do we have the n minus 1 here in the first one, this definition, which is the one that we're more often going to use? It's because we started with the first term and not with the 0th term, okay? And so that n minus 1 is just going to offset it a little bit. It's not a big deal. I would say that that would be something that you probably want to tuck away. We're going to use it quite often, okay? D is the common difference between consecutive terms, okay? And D is going to be pretty easy to find. If we want to define it, we can say A sub 0 is equal to A sub 1 minus D, okay? So if you look up here, back at the first example we did with 4, 9, 14, we knew that A sub 0 was 4. We knew that A sub 1 was 9. We knew the common difference was 5. So we would have 9 minus 5, which is equal to 4. Hey, it works. Okay. So, just don't forget that D is the common difference. And then the rest of them, when I say A sub 0, I mean the 0th term, you're usually not going to, have the 0th term. It's usually going to be first term, second term, third term, fourth term. Okay. So don't get confused by the terminology. All right, so example 2 here. Find the formula for the nth term of each arithmetic sequence. First things first, okay? If we want to find the formula for the nth term, we're going to say A sub n. Now, for letter A, they just straight up gave us all the information we need, okay? And that is the first term, which is 13, plus, we know what the common difference is, so we are just going to say n minus 1 times negative 4. Now, you might be going, is that it? No, we're going to simplify this because we have like terms that we can combine. So this is just algebra 1, basically. Distribute that, and we've got 13, negative 4n, and negative 4 times negative 1, positive 4. And so A sub n is going to be equal to 17 minus 4n. Put those common terms together, those like terms together, and simplify it as much as you can. Okay. And now the nice part is we could find any term that we wanted. Let's say that and they didn't ask us for this, but let's say that we wanted to find the 10th term. All we have to do is plug in 10 for n. So we'd have 17 minus 4 times 10. 17 minus 40. The 10th term is negative 23. Does that make sense? Okay. We didn't need to find that, so I'm going to scratch it out. But hopefully that's the point of this, the purpose of this. Okay. So B and C, they all of a sudden just gave us a bunch of terms. Now, the one major thing here is that unless they specifically tell us we're starting with the 0th term, you assume that we're starting with the first term. So for letter B, we know the first term is 11, and we also know what the common difference is because we're just looking here. The common difference is positive 4. Okay, so I'm going to start in the same spot that I did with letter A and say A sub n is equal to 11 plus n minus 1 times, this time, regular old positive 4. If the sequence increases, D is positive. If it decreases, D is negative. So I got 11 plus 4n minus 4 I have, if I'm not doing anything wrong here, 7 plus 4n, or 4n plus 7. Does it matter which order you put them in? It does not. If somebody writes 4n plus 7 here, we're going to take that. It's not a big deal. It probably is better, truth be told, to say, just because this is how we've been doing it for, 5 years now, since we started Algebra 1, putting your constant at the end. So that's probably better. Okay. On to letter C. This one you might be going, whoa, this is weird. I already have too many letters, Mr. Ernst, and I have all these A subs and all this stuff. Not a big deal, okay? So ask yourself, what is the first term? And if you look right there, you say, hey, A sub 1, the first term is A. Second thing, what is the common difference? Well, how am I getting from each of these terms to the next? Although they look funny, the first term right here and the second term tell you. All you did was add 2. So my first term is A, and my common difference is plus 2. So A sub n is equal to A plus n minus 1 times 2. All I'm going to have to do here is distribute and write it out nicely. A sub n is equal to A plus 2n minus 2. Done. Okay. So really an arithmetic sequence is kind of like a linear equation. Okay, in that you're going to have an n in all of them. You're going to multiply it by something, and you're going to add or subtract a constant. So you should be thinking about arithmetic sequences kind of like you do linear equations. If that makes you feel very comfortable, good. That's a good thing. All right, 2 more here. We got actually, good thing I set my DVR. You guys are, or maybe your parents are watching Last Dance tonight, the Bulls documentary on ESPN. I gotta get to that here. So let's finish up example 3 and 4. Find the 29th term of the arithmetic sequence whose 5th term is 25 and whose 11th term is 55. Okay, I'm going to write out the stuff I know here. I know that A sub 5 is 25. I know that A sub 11 is 55. I also know that there are 6 steps, okay? 6 common differences to get from the 5th term to the 11th term, okay? So I'm actually going to write that out here. A sub 11 is going to be equal to A sub 5 plus 6d, okay? Now, why is that the case? Well, if you can picture here, A sub 6, A sub 7, A sub 8, A sub 9, A sub 10, hey, A sub 11. How many little hoops do I have there? 1, 2, 3, 4, 5, 6. And so that's the beauty of arithmetic sequences, is they're consistent. And so now we can fill out what A sub 11 is. So that's 55. I got to flip back to my pen here. 55 is equal to 25 plus 6d. We're trying to find out what d is. This is just a regular old linear equation now. Subtract 25 from both sides. And we've got 30 is equal to 6d. If I didn't do anything wrong, that makes d pretty simple. Our common difference is 5. Okay? And so we now need to find the 29th term. Okay? So I have a choice here. I could go back and try to find out what the first term is. That doesn't make much sense. I'm going to use my brain here and say that, I want to find the 29th term. I'm going to say that A sub, that's sloppy. Let's erase that, Mr. Ernst. There we go. A sub 29 is equal to A sub 11 plus how many D's? How many common differences do I need to add, guys? If you said, Mr. Ernst, I need to add 18 D's, you are 100% correct, because to get from 11 to 29, you would have to take 18 of these little steps that I'm pointing off to on the right. Okay, so we know all this stuff. A sub 29 is what we're looking for. A sub 11 right here is 55. 18 times our common difference at the bottom here was 5. 18 times 5, if I remember correctly, is 90. 55 and 90 make 145. So my 29th term is 145. Basically, arithmetic sequences are just counting guys by the same step from each term to the next. Okay, and my last one here, example 4, find the 10th term of an arithmetic sequence that begins with 8 and 20. By begins with 8 and 20, they mean those are the first two terms. So we're going 8, 20, ... Well, if you're saying, I know a bunch of stuff, you're right. First and foremost, we already know our common difference. How do we get from 8 to 20? We add 12. Okay. What is our first term? It's 8. So they are asking us to find the 10th term. I think on this one, I would probably just jump to that important formula I told you, which was a sub n. A sub n is equal to a sub 1 plus n minus 1 times d, which in this case is 12. Okay. A sub 1 is 8. So I know that my general formula is going to be whatever that is equal to, 12n minus 4. So my general formula is 12n minus 4. And now what's super nice here is we know what n is. N represents always the term number. N has been all the week long, or week and a half or 2 weeks, however long we've been doing this, the term number. So if we want to find the 10th term, what are they asking us for? They're asking us to find a sub 10. Well, let's just go back up there and chuck 10 in for all of our n's. So a sub 10 is equal to 12 times 10 minus 4. That's going to be 120 minus 4. And our 10th term then, ladies and gents, is going to be 116. Perfect. Okay. So you guys have, I do believe, just the first half of that worksheet. Check it out on Haiku for arithmetic sequences. I will jump on here and do the sum of arithmetic sequences in a little bit. But good luck. Let Ms. Fulling, myself, Mr. Geschwind, or Mr. Moore for that matter, know if you guys have any questions. See ya.